Once again, good morning, everybody, and welcome to our Mathematics 9 class today. Today, we're going to learn about parallelograms. Yesterday, we have learned about quadrilaterals, and that a quadrilateral can be a trapezium, no sides are parallel. It can be a trapezoid, only one side, only one pair of sides are parallel. The other pair is non-parallel. And we have learned about parallelograms, where two pairs of opposite sides are parallel. We also have the kite, rectangle, rhombus, and square. And this morning, we will learn more about parallelograms and its properties. Let's recite today's memory verse, and it's found in Ezekiel 42, verse 20. It says, "He measured it on the four sides. It had a wall all around, the length 500 and the width 500, to divide between the holy and the profane." Your MVCA booster today is about parallelograms in the Bible. You need to post or draw a design that shows how parallelograms are used as designs in buildings or objects during Bible times. Support with a Bible text. So it can be a design of a building, or it can also be an object. Now, at the end of today's class, we'll be able to determine the conditions that make a quadrilateral a parallelogram. Second, use properties to find measures of angles, sides, and other quantities involving parallelograms. And the third one is to prove theorems on the different kinds of parallelograms. Now, here's our venture activity for today. We need to plot the points in the Cartesian plane and connect each given set of points consecutively to form a quadrilateral. Now, let us assume this is 1, 2, 3, 4, 5, and the other is also 1, 2, 3, 4, and 5. So let us make an assignment. You can annotate, okay? You can feel free to draw on my board. Number 1, AP with a red. Please follow your color, okay? Then the next, Ali. Ali is here, right? Ali. Number 2. You can draw them all together at once. Then for the green, number 3, let me ask Janine. For number 4, let's have Tatiana. Then we'll have the pink. Let's ask Faith. And number 6, the violet. Let's ask Ryan. Okay, ready? Start annotating. I'll give you 1 minute to annotate. To plot the points, again, you plot the points in the coordinate plane and then connect them. Now, let me go to Tatiana. There, Tatiana is starting to draw hers. So 3, 4, Baba. This one, correct. 2, 2. This is 2. 2, dapat bilang isa. Ani. Next, 3, 0. So this is the other one. Next, 4, 2. 4, 2. Okay, this one is 4, 2. Let me connect now, Tatiana. This is the one. 1, 2, 3, 4. There. Is it a parallelogram? Actually, yes, it is a parallelogram. So the rest, thank you so much for helping me in drawing our different quadrilaterals. Let me now clear all the drawings there. Wait first. Okay, now let's go to our chat to the expert. Now, what is a parallelogram? Yesterday, we have learned that a parallelogram is a quadrilateral whose pairs of opposite sides are parallel. Our keyword is parallel. So these two opposite sides are parallel. The other opposite sides are also parallel. Now, how do we write them in symbol? If you see the two bars there, that means it's parallel. Like this one, it means parallel. So we say side AB, there must be a bar on top, is parallel with side CD. In a figure, this is how you draw parallel. If you have this symbol, it means the ones with only one triangle are parallel. The ones with other two triangles are also parallel. Actually, you draw it this way. This one, like that. And we say that BC is parallel to AD. Now, we have some theorems. Now, what is a theorem? In mathematics, especially in geometry, we're now in geometry, we keep on hearing the word theorem. Now, a theorem is a statement that is only accepted if there is a proof. The other is what we call a postulate. A postulate is a mathematical statement that is already accepted even without a proof. For example, they say God exists. Even if there's no proof, we accept that. So that is a postulate. But if you say theorem, you need to have a proof. Example, you'll say, I am beautiful, I am handsome. That is a theorem. Why? We need to have a proof. What's your evidence that you are beautiful and handsome? So let's start with the first theorem. The first theorem states that opposite sides of a parallelogram are congruent. So for example, if ABCD is a parallelogram, then the opposite sides, AB, we say AB is congruent to CD. And this one, AD is congruent to BC. So if AB measures 10, DC will also measure 10. If AD will measure 5, BC will also measure 5. Reason? Opposite sides of a parallelogram are congruent. Now, let's have this example. You need, here's the proof for that one. Now, let me go with the first proof on why opposite sides are congruent. Example, ABCD is a parallelogram. So with that, in the second, ABCD. So AB is parallel to DC, and DA is parallel to CB. Our reason? That's the definition of a parallelogram. Remember, in the alternate interior angles theorem, BAC, this angle is equal to this angle. The reason for that is alternate interior angles theorem. And AC, let's draw here. AC is equal to AC. That's the reflexive property. So therefore, this triangle is equal to the other triangle. The reason, ASA postulate. Why? It's angle, right? Angle, side angle. This is equal to this. This one is equal to this one. So ASA. Therefore, their corresponding parts are also congruent. Now let's have the corollary. A corollary is a sub-statement of a theorem. What's the corollary? If two lines are parallel, then all points on one line are equidistant from the other line. Example, this is AB and this is CD. If two lines are parallel, if AB is parallel to CD, then any line from AB to CD are all equidistant. What do you mean by equidistant? It means they are equal in distance. Let's have the next theorem. The next theorem states that opposite angles of a parallelogram are congruent. Example, if ABCD is a parallelogram, then opposite angles. Angle A is congruent to angle C, and angle D is congruent to angle B. So, if angle A measures 100 degrees, then angle C, they are opposite angles, will also measure 100 degrees. Next, the third theorem states that consecutive angles of a parallelogram are supplementary. For example, if ABCD is a parallelogram, then A and B are called consecutive angles. What will happen? The sum of their angles will be 180 degrees, supplementary. So if angle A measures 100 degrees, then angle B will measure 80 degrees. Now, let's go to the next one. The next theorem states that the diagonals of a parallelogram bisect each other. Example, if ABCD is a parallelogram, then their diagonals will bisect each other. It means that if if AC measures 12 cm in all, then it will bisect each other. They will be cut into half. So AE will measure 6 cm and EC will measure 6 cm. If DB measures 10 cm, then it will bisect each other, right? The diagonals bisect each other. Then DE will measure 5 cm and EB will measure another 5 cm. Any questions? No questions? Let me go to the next one. Each diagonal of a parallelogram divides the parallelogram into two congruent triangles. So if there is a diagonal here of a parallelogram, then it means that this triangle ABC is congruent to triangle CDA. Now, let's talk about conditions. How will you know that a quadrilateral is a parallelogram? Now, again, how will you know that a quadrilateral is a parallelogram? Here are some theorems. Actually, these are the opposites of the ones that I told you a while ago. Now, if this is a quadrilateral and the pairs of sides, two pairs, again, if two pairs of opposite sides are congruent, then it is a parallelogram. Second, if only one pair, if only one pair is congruent, but that pair is also parallel, see the parallelogram sign, parallel sign, then it is a parallelogram. The next one, if the opposite angles of a quadrilateral are congruent, like A is equal to C and D is equal to B, then that quadrilateral is a parallelogram. Next one, if the consecutive angles, like example, A and B, once you'll add them, the answer is 180 degrees. If the consecutive angles are supplementary, then that quadrilateral is a parallelogram. Next, if the diagonals bisect each other, then that quadrilateral is a parallelogram. Now, let us have this exercise. Let's find the values of x and y in the figure love. Now, example. For example, this one. Let's start first with x and 2x minus 10. Now, what is the relationship? Can you tell me in the chat box? Or you can...
X.
Yes, what's the relationship, AP?
X, ma'am.
X. How do you describe this one? LO and EV.
L congruent to EV.
Very good. These two are opposite sides, right? This is a parallelogram. So they are congruent. We say they are equal. So we say x is equal to 2x minus 10. Let's solve for the value of x. Transfer to the other side. X minus 2x is equal to negative 10. So we have negative x equals negative 10. Divide both by negative 1. Our x is equal to 10. It means this is 10, right? The other one, if you substitute it, 2 times 10 is 20 minus 10. It's also 10. So they are the same. So let's substitute here. 1/2 of 10 is 5. Remember these two. What's the relationship of LE and OV? What's the relationship of sides LE and OV?
None.
Remember, they are also congruent. Opposite sides of a parallelogram are congruent. So they are equal. So we say the value of y is equal to 1/2 x. Our x is 10, so our y is equal to 5. Any questions? Let's go to the next example, okay? Now, here, okay, you check. What's the relationship of LO and EV? What's the relationship of LO and EV?
X an equal number.
Dili, ang side. Diba? What does a theorem state? The theorem states that opposite sides of a parallelogram are congruent. They're equal. So LO, this side, is congruent to side EV. So you have, let me transfer that one. EV is congruent to LO. They mean the same. So we have 5x minus 12 is equal to 2x plus 3. Let us transfer this. We do transposition. And the other one, plus 12 So we have 3x equals 15. Divide both by 3. So our x is equal to 5. If you check, LO is 2 times 5 plus 3. That's 13. And EV is 5 times 5 minus 12. That is still 13. So these two are equal. Let's go to the next one. Okay. What's the relationship between angle L and angle V? What's the relationship between angle L and angle V? Can I ask Janine? Sige, Janine, what's the relationship between angle L and angle V? Sorry. How about Ali? What's the relationship between angle L and angle V? No, they are not supplementary. You look. How do you describe angle L and angle V? Are they consecutive or opposite? Are they opposite or consecutive? L and V. Oh, very good. They are opposite. Now, opposite, remember the theorem states that opposite angles of a parallelogram are congruent or supplementary? Opposite angles of a parallelogram are congruent or supplementary? Yes, AP.
Congruent.
Very good. They are congruent. So if they are congruent, then the measure of angle L is equal to the measure of angle V. So L is congruent to V. So we have 2x plus 4. It's equal to 120. Let's solve for x. 2x equals 120 minus 4. So 2x is equal to 116. Divide it by 2. X is equal to 58 degrees. Now, how about L and E? There. What's the relationship between angles L and E? Are they consecutive or opposite? May I hear from Tatiana? L and E. Very good. They
Consecutive, ma'am.
Okay, so if they are consecutive, are they supplementary or congruent?
Supplementary po.
Very good. They are supplementary. So once you will add them, it's equal to 180. The same is true if you have E and V. They are also consecutive. So the answer should be equal to 180. So 3y plus 9 plus 120 is equal to 180. So 3y plus 129 equals to 180. 3y equals 180 minus 129. That will be 3y equals what? 51. Divide all by 3. So our y is equal to 27. By the way, my Zoom session is about to end. Let's leave first, then come back right away, okay?